Okay, the velocity v at time t of a particle p of mass 2 kilograms is given by this. Given that p at the point with position vector minus 2I minus 2j plus k when t equals 0, find the position vector of p at time t seconds and deduce the distance of p from the origin O when t equals 1. Okay, so you've got this here, velocity given in terms of vector, unit vectors here, I, j and k, right? And remember, velocity is the derivative of displacement. Displacement in vector form we always write as r, right? So not x or s, we don't use that. With vectors it's always r to represent the position vector. So in this case here, we've got the velocity, so this would be dr by dt, won't it? That's what we've got there for velocity. So 3t squared I minus 2t j plus 4k is the vector for the velocity there. And of course velocity is the derivative of the displacement or position vector dr by dt. Notice the underline vector values here because they're in bold here, but we underline them when we write them, so it is r underlined. So to get the position vector, right, because that's what it's asking for, isn't it? Find the position vector p at time t. We integrate, okay, separate the variables, okay, and you get r on this side, and you get t cubed on that side, you get t squared on that side, and then you get 4t here. Of course I need to put my ij's and k's in, I forgot about them. Okay, plus then a constant, right? Now when I do the constant, it says, look, position vector is this when t equals 0. In other words, when t equals 0, r will equal minus 2I minus 2j plus k. So put that in. T is 0, so all of that will go, so you get your c then. So in effect then r will equal, now if we put the c in there, then as we worked it out, I'll put the i's together, so you get t cubed minus 2I. Put the j's together, so you get minus t squared minus 2j, and then put the k's together, 4t plus 1k. Alright, so there's your position vector at time t. You've done that now, you've answered most of part A. Then it says deduce the distance of p from the origin when t equals 1. So to get the distance, you look at where the position is. When t equals 1, r will equal, so you put 1 in here, so you get 1 cubed minus 2I minus 1 squared minus 2j plus 4 times 1 plus 1k. So the position vector will be minus I, that would be minus 3j, and that would be 5k. That's the position vector, where it is in terms of a vector. But to get the distance, you need to look at the actual size of this, okay? So the modulus, to use Pythagoras and the modulus, so basically you square everything and then square root it. So there you've got minus 1 all squared, then you've got minus 3 all squared, and then you've got 5 all squared, and the i's and j's and k's disappear. So this becomes, if you use a calculator, I don't have to worry about the minuses because they will disappear. You square, so you get root 35. Okay. B. The acceleration of p at time t is denoted by A. Find an expression. While if you know velocity, of course, is this. Plus 4k. To get the acceleration is just dv dt, isn't it? Okay, so you get 6ti minus 2j, and then, well, 4k is constant, so it disappears. So you've got 0k, and I don't need to write that down. Okay. And then part C, show that the direction of A is perpendicular to OP when t equals 1. Now remember, when it says OP, it's talking about the position vector, right? It's talking about the position vector of the particle. The position vector of the particle is always relative to the origin. So OP is basically R, okay? when t is 1. Now, didn't we work that out earlier? I'm sure we did. Yeah, we got that there. Okay, so we've got the position vector there. Okay, and it says show that the direction of A is perpendicular to OP when t equals 1. So what we need to do now is, if we set t to equal 1, so we'll make our A to be 6i minus 2j, and then we'll dot the product of r and I, and we'll see what we get. Okay, so r dot A, the position vector, and the acceleration, we've got that turns out to be, if you dot times the i's together, you get minus 6, times the j's together, you get 6, and times the k's together, well, there's nothing there, so it's 0. So you get 0, so therefore perpendicular. Okay, excellent. Question answered.